Welcome to Math 119, Chapter 3.3, where we're talking about quadratic functions and this time how to graph them. So if a linear equation has a degree of 1, so think about the format of a linear equation. Y equals mx plus b, or y equals ax plus b, right? The degree on top of your x is 1. So your degree is going to give you an insight as to how many solutions you might be having. So therefore, a quadratic equation, being the next step up, has a degree of 2. Now, those equations look like y equals ax squared plus bx plus c. Now, we talked about ordering these in descending order. So your highest degree first, and then your next highest, and then your next highest or your lowest. So we're going from high to low here. Now, there is a reason that we do that for sure, because when it is in this quadratic function form or your general form, like down below, A, B, and C, these are just signifying different numbers or numerical values that your quadratic can take on. And the reason why we want to have them in descended order is because of your leading coefficient. Your leading coefficient, so, is always attached to your highest degree. So finding the highest degree and attach to it the numerical value, this being your leading coefficient, will tell us the shape of your graph. Now, this is why we call this your quadratic term. So this is your quadratic term. So quadratic term, because if A is greater than 0, you are concave up. So we're going to be going up. So A is greater than 0 means that A is positive. Whereas if A is less than 0, so if A is negative, we're then going to be concave down. So that's why our leading coefficient, we want to have it the very first one, so in descended order. So that provides us with the direction. Now you'll notice that A here is not able to be equal to 0, because if it is equal to 0, that just makes this whole first term go away, and then you're working with a linear term or linear form. So if that's a quadratic term, this middle one is called your linear term. Numerically, B doesn't give us much just by looking at it. We can use B to help us manipulate the equation and find your vertex, which we'll talk about here in not too long. Now, your C also has a special name. This is called your constant. Your constant being your y-intercept, where x is 0 and y is your number. In this case, y is going to be c. So by looking at your equation, you can then automatically see your y-intercept, as well as determine the shape of your graph. This is before we can go ahead and get started when we graph today. So this is your setup for your quadratic equation. Again, we're going to be talking a lot about some of these terms here in a moment. So it says the graph of a quadratic function is U-shaped, and this is referred to as a parabola. So let's get familiar with the anatomy of a parabola. So let me go ahead and draw just a very quick parabola. So you'll notice that it's U-shaped. Now what I would like you to do is pause the video and see if you can pick out just the important key features of your graph. So I've had students give me lots and lots of different responses here. Some have told me this is a function, which it is by using the vertical line test. Others have given me the domain here. Being all real numbers, you'll notice there's no gaps or anything to take into account. Range is a little bit harder to do since we don't know the numerical numbers of these graphs, but we could estimate it. Let's say we do assume that these go up by 1. Your range could then be, let's say, keep it nice and even, would go from -3 to infinity. So I got lots of those types of responses, which is really great that you are kind of expanding outside of the box. But some other key features that we're seeing, right? X-intercepts, how many do we have? Well, your x-intercepts, we can have at most 2. So we can see your x-intercept here, and we can put at most 2. So if you have your x-intercept, we also have your y-intercept here. Your y-intercept being where your graph meets the y-axis. Keep in mind these intercepts. Your x-intercept, x is going to be a number and y is going to be 0. And your y-intercept, x is going to be 0 and y is some number. Now, some important other features is that we have this portion of your graph right here. Anybody know what that is called? So this is called your vertex. If you said it's a minimum, absolutely you would be right. You do have a minimum of your graph. Minimum is just the smallest value. So we're lying in a hill, whereas the opposite is if we had a maximum. So your graph has had having a peak, the highest part of your graph. So your vertex, though, coming back to just very standard wording of it, is going to have a special point. We call this special point HK, and that comes into play when we talk about your vertex form on your next page. So this is where your lowest or your highest X and Y value, your lowest or your highest Y value is going to occur. Now, another key feature of this graph is that your graph is perfectly symmetrical, meaning that we can cut your graph in half, and what's happening on the left-hand side is mirrored to also the right-hand side. Now, this is called the axis of symmetry. So symmetry being symmetrical. Now, this has an equation. This says x is equal to negative b over 2a. Now, on your tests, you're likely not going to be given this axis of symmetry equation, but when you do your homework, your quizzes, when you're practicing it on your notes here today, you're going to be using it quite often. So you don't have to memorize it through just the practice of the motion. So now, what's the relationship between this axis of symmetry and the vertex here? Well, hopefully we can notice that the axis of symmetry, x is equal to negative b over 2a, is actually represented in this x or your h. So we can write your vertex as negative b over 2a. That is your x value. And to find your y, well, we're given an equation, most likely. So we can just sub in your x into your equation to find your y. So plug in x to find y. So those two features of your graph are going to be really important. While we're graphing today, you're going to notice that we're looking for your x-intercept, y-intercept, vertex quite often for these practice problems. Now let's talk about standard form. So standard form, so what we did was just like a very general form, but now we're going to be looking at standard form. Standard form is another way to say vertex form. On your test, I'm going to just use vertex form. On your homework, it will likely just say standard form. Now, this is just a different way to write your vertex. Think about all of the, not your vertex, your quadratic. Think about all of the different ways that we wrote an equation of a line, right? For your equation of a line, we had y equals mx plus b. We had y minus y1 is equal to m, x minus x1. We also had ax plus by is equal to c, right? There was many ways to write your linear equation. Same idea here, except now we're going to be using your vertex to make the vertex form, kind of like you had a point to put in your point slope. So what we're going to do is we're going to be taking what we have from your general form, and we are going to be making your new form. So we have f of x is equal to a. Now this a signifies the a from right directly above it. So if you have that leading coefficient, it's also going to be your leading coefficient over here. X minus h squared. So this squared means that it's going to be that quadratic. Lots of students forget to put this squared on a test or a quiz, which does result in points off. So just don't forget to square your parentheses. And then we're going to say plus k here. Now that hk is coming from just the point of your vertex. So it's really just the h being your x value of your vertex, k being your y value. Now you'll notice that in this form here, I'm just writing a positive h and a positive k. Now, if in your equation you have that negative, and let's say h is negative. Well, in our form, actually, I'm going to put that part over here. So sorry, let's say h is positive. So as we saw from your point in our last page, we just wrote it as a positive. And what's going to happen, very much like we did in your point slope form, is that you're going to undergo a sign change. Now it's only going to undergo a sign change for your h, because let's say h is positive. When we go to say minus a positive h, well, the negative times a positive makes a negative. Whereas if h is negative, then we say negative times negative h to then undergo the sign change. Now, k will not undergo a sign change, because if it's positive, when we go to add your k value here, there's not going to be any sort of cancellation. Let's say if it's negative, we can say plus a negative k, which then we just subtract the k. So no sign change for k, sign change for h. Only, I'm going to maybe put it over here. Only sign change for h. Now, when we start to focus on your vertex a little bit more, right? If you have a vertex that is down low, this is going to be your minimum. So if it lies in a valley, it's a minimum, whereas on your peak, it's a maximum or a max. Now, lots of students, that hopefully made some sense, right? Maximum, you're at a high point, and minimum, you're at a low point. But when students are rushing on a test, on a quiz, on their homework, this is one of the first places they lose points, is because they're not really thinking about the process. So just think, whatever your graph looks like, just slow down, get the point for just telling me if it's a max or a min. Now, this minimum will occur if your a value here, the same a over here, if a is greater than 0. So if a is positive, we're going to have a minimum value. We're going to be concave up. We're going to be going upwards. Whereas we'll have a maximum when a is less than 0. So if a is negative, we're going to be concave down. And when it asks about concavity, we use the term concave down and concave up. So if you're being asked what type of concavity you have, it's either up if it's minimum or down if it's a maximum. Again, points off here sometimes. If you're going too quickly, please just slow it down. Now, when it's in your vertex form, right? So point slope, right? We're given your slope and your point. Vertex form, you can pick out your vertex very much like you can pick out your point. So for example, here, when it says find the vertex and graph, first off, let's figure out where your vertex is. So in this form, keep in mind we have y equals a x plus h, or sorry, x minus h squared plus k. Now, in our form, right, this h here represents this number here. So part of your vertex is going to be 3. Keep in mind, we undergo a sign change. In order to put the 3 back in, because this is your formula, right, we need to have a positive 3 so that we can do minus a positive 3. Whereas if we said, oh, this is really negative, when we go to put it back, we're doing negative times negative 3, which then changes your sign here. So always do a sign change for your h. And then where is your k? Well, it's missing. So what can we add to your equation to make it so that it doesn't change? Well, we can add a 0, right? Normally we just drop that 0 because it's insignificant. So we can just say, well, your k value is now a 0. So then what does that mean for your axis of symmetry? Well, your axis of symmetry, we said, has a correlation with your vertex form here. It is the h of your vertex. So we don't need to write, we don't need to expand and put it into, let's see, general form. Instead, if you have your x value of your vertex and it's asking for your axis of symmetry, we're just going to say x equals that value. And you do need the x equals because it is a line. Need x equals because it is a line. So on a test, I will take off points if you don't have x equals and that value. So now let's figure out some points. So actually, before we figure out points, let's put your vertex on the graph. So we said it's 3, 0. So locate 3, 0 on your graph. Right there. Now let's kind of determine the direction. So let's get an idea for what this graph is going to look like. Again, we're going to use your A. A is your leading coefficient, which determines, are we going to be concave up or concave down? So where's that A located? Well, A is located right here in front of the parentheses. And if we don't see it, we can assume it's 1. So because A is equal to 1 is positive, we can conclude the shape of your graph to be upward facing. So because A is greater than 0, we're going to be upward facing, so concave up. Now, if you have a hard time remembering if it's up or down, you can kind of spell the word up with the word or with the shape of it. So we are concave up here. So at the end of the day, our vertex is going to be at a minimum. So our graph should look like this. So let's go ahead and determine points. So we talked, or actually in our next chapter, in our next section, we're going to talk about how to graph in a smart way. So we want to come up with some strategies. So when you are given your vertex, or when you find your vertex, we typically want to go to the left and to the right of your vertex, immediately to the left and right. Those typically give us good points as we get started. So we definitely want to put your vertex on your, there we said 3, 0 being your vertex. So to the left and to the right, we have 2 and 4. So when we go to plug these values in, right, we only need to, let's see, actually, let me do it above, g to the 4, nope, g to the 2. We're going to take your equation and we're going to plug 2 into your equation. So 2 minus 3 is -1 squared, which is +1. So you have the point 2, 1. So we can go ahead and add that into your graph. So 2, 1 being right here. Now keep in mind your graph is perfectly symmetrical, correct? It's mirrored. So that just means what happens on one side of the graph happens directly on the other side. So directly to the other side of your vertex, we should have the point 4, 1. Now, if we wanted to prove that, we could always go ahead and plug it in. Let's see, 4 minus 3 squared, which is equal to 1 squared. So it's 1, 4, comma 1. So you can use the process of just the symmetry of your graph to lessen the amount of work for you. So you didn't have to do this part of it if you didn't want to. So it's just a mirror. Now I do ask that you graph usually a minimum of 5 points. So then we can start to expand. So what are some other points? So if we have 1 to the left and 1 to the right, what are some other points that we might want to consider? Well, we might want to consider going 2 to the left and 2 to the right, or maybe 3 to the left and 3 to the right. So it doesn't matter which one you choose. I might choose to put 1. So g times 1. So that's 1 minus 3 squared, which is negative 2 squared, to be 4. So we have 4 comma 1 here. So if I add that to my graph over here, 4, 1. So taking your point, your symmetry line, we went 2 over to the left, then we can go 2 over to the right, and that allows us to bypass us having to put g of 5 into your equation. So we have 5 comma 1. Not 1. I switched these, didn't I? 1 comma 4. You put in a 1, you get out a 4. You put in a 5, you get out a 1. There we go. And that should be all 5 points. If you wanted to do more, you can add 0, or if you wanted to skip some other ones and do 0, that's okay. Just remember, when you plug in a 0 here, that doesn't change your value. It doesn't come out to be 0. Comes out to be 9. So 0 comma 9. And this being 3 away. So if we have your symmetry line and putting your point on there, and again, I only ask that you graph 5 points, so we're doing a little extra work. So if this is your symmetry line, we went 3 to the left of your symmetry line. Then by going 3 to the right, we have this next point, 6 comma 9 is your next one. So if you wanted, you could do 6 comma 9. Now, I do have students that don't connect the dots. I will be taking points off if you don't connect the dots. Just really quick and easy, as best you can. Connect the dots. So why don't you try it again on your next one? So let's see, your vertex here. Your vertex is 1. We want to undergo a sign change. 3. So no sign change for your k value. Your axis of symmetry is x is equal to -1. So let's go ahead and plot that on your graph here. So we have -1, 3. We're all the way up there. We are nice and symmetrical. On a test, you don't have to graph the axis of symmetry line. I do think it's still helpful though. So we have f of x is equal to -2 x plus 1 squared plus 3. Okay. So if we have -1 here, thinking about going 1 to the left and 1 to the right, that puts us at putting in -2 and 0 in. So I might choose to do 0 into my function, -2 times 0 plus 1 squared plus 3. is negative 2 times 1 squared plus 3, which is negative 2 plus 3, or just 1. So we have the point 0, comma 1 when we plug in a 0. Oh, and your vertex, I'm going to make your vertex special. Negative 1 and 3 here. So your other point, we said 0, 1. This happens to be your y-intercept. And it allows us, if we're using just the mirroring process, this being the axis of symmetry. So just as if we go 1 to the right, we can then go 1 to the left, and we have your next point. That next point being negative 2, comma 1. Now I do ask that we do 5 points in total, so we just need a few more here. So let's do 1. So just expanding it outwards just once more. So you have f of 1 is equal to negative 2, 1 plus 1 squared plus 3, 2 squared plus 3, negative 2 times 4 plus 3, negative 8 plus 3. So we're at negative 5. So we have 1 comma negative 5, which means we can find our another point, negative 5 right here. So if this is your axis of symmetry, we went 2 to the right. Now let's go 2 to the left, and you're at your next point here. You're at that point being negative 3, negative 5. Connect your dots. And there you go. Negative 3, negative 5. That's if you put in a negative. So that's if you wanted to graph, or if it's in vertex form. Notice that it's pretty easy to get some of those points onto your graph. Now let's think about this vertex as being a transformation. So can you pause the video and just very, very quickly identify your vertex, and then go ahead and give a very quick picture of what your graph is going to look like. So for ours, we have f of x is equal to x squared. So this is actually called your parent graph, or parent function. And I'm going to write that down here. This is what your parabola looks like without any changes being made to the graph. So because you don't have an x, or not an x, but an h here and a k, we can go ahead and substitute in a 0 just to show that we haven't made any changes. They've just taken out all the fluff. So in our case, your vertex is going to be right smack dab in the middle at your origin, and your a value being 1 here. If you don't see it, it's a 1. We're just going to extend your graph upwards. So your parabola should be an upwards facing parabola. Now next here, we have x minus 2 squared, or all squared, meaning that your vertex here is at 2 comma 0. So 2 comma 0 over here. And again, just a quick graph. Now, how did this first graph then transform to the other graph? Well, looking at your vertex, if your graph used to be here, if you used to be there, to go to your next graph, you went to the right by 2. So going to the right by 2 is showing you that this negative 2 here, right? Because we really believe that your vertex is positive, it undergoes a sign change. So we are transforming your graph. All that your vertex form is a transformation. So when we want to go to the right, we have a negative. So anything on the inside of your graph, or inside of your parentheses, will shift your graph left and right. which means for your next one, if you can, right? We started here. We then moved over here, and we're going to end your graph at -2, 3 being right here. So how did here go to your next graph over here? Well, we already said, well, we've shifted it over 2, but now we're going to go up. Up by how many? Up by 3. So notice that that 3 here is going to be shifting your graph up. So this K value shifts the graph up and down. Up when K is positive, down when K is negative. Now we're going to talk all about these transformations when it comes to your next chapter. So 4.1, we'll talk all about transformations and why they appear this way. So just think about your vertex for now is that on the inside, it's going to shift left or right. And on the outside, it's going to shift up or down. Now let's go talk about a little bit more graphing methods, but this time when your graph is no longer in vertex form. So you'll notice that the form down here is just in that general form. Now, because it's in a different format, what we need to figure out is how to graph it in a different way. Now, thankfully, we have some steps for you to follow here. So it says determine concavity. So first, we're going to determine your concavity by looking at your A value. So your A, if it's greater than 0, we said we're going to go up. Or if it's less than 0, we're going to go down. Think about spelling the word down, D-O-W-N. That portion is like your N. So first, get an idea of what this looks like. Second, find the axis of symmetry. So that has your x is equal to -b over 2a. That's the little formula that we get to use because it's that symmetrical line. Now the b and the a is just coming from your format of a quadratic of ax squared plus bx plus c. So b being this linear term and a being that first a over here. So once you have your x value, what we then get to do is use your x value as part of your vertex, right? That's half of your vertex. So then we just get to plug it into your equation. So plug it in. Plug x into equation. Next, we're going to be finding your intercepts. So if we're looking for your x intercepts, we're going to factor. If we're finding your y intercepts, we're going to be taking your constant, your coefficient, your constant of c, or you can plug in a 0 for your x. Lastly, we're going to be finding additional points. So if we don't have all 5 points, then we have to pick points and evaluate. Okay. So we're going to skip A for now. And if you would prefer starting with A and then using kind of this method to locate where your graph is, we can certainly do that. But I'm going to skip A and come back. So first, let's go ahead and find your vertex, which is what we would have to do either way. So step 1, figure out your A. So what is your A equal to here? Well, your A is equal to -1. So if you wanted as well, you can kind of define what A, B, and C are. A being -1, B being -2, and C being +3. So if that's something that you think would be helpful before getting started on any sort of problem, that's probably one thing that you could do quickly. So A being -1, are we going to be concave up or concave down? We're going to be downward facing, which are we then going to have a maximum or a minimum? We're going to have a minimum. So at the end of the day, that is what your graph should look like. If you're noticing that's not what it is matching up to be, then we've done something wrong. So next, let's go ahead and find the vertex using negative b over 2a. So we said b is -2, so we can just go ahead and insert that. So we have negative times -2 over 2 times a being -1. Now be careful, there's a lot of negatives going on. One from your equation, one from the -2, and one from the -1. So while some of them are going to cancel, we still have one left over. So we have -2 over 2, which means it's -1. So x is equal to -1. So this is the axis of symmetry here. So that's going to cut your graph in half. And so when we look at the third step, we're going to take your x is equal to -1, and we are going to plug it in. Plug it into your equation. So if we have f of x is equal to -x squared minus 2x plus 3, we're just going to erase your x and plug in the -1. So -1 replaces your x values, and then we can go ahead and evaluate. So we have -1. So -1 squared is just +1 times your negative. So get -1 plus 2 plus 3, which means we're left with 4. So your step 3 provides you now with a full picture of your vertex. Because notice that the first time we do it, we have -1, but we don't know what your y coordinate is. So this y coordinate is now 4. So let's go ahead and plot -1, 4 on your page. So that is right here. We're just going to be going up by ones. As best you can, label, give some context to your graph. So right now we have 1 point, and we want a total most likely of 5 points. So let's go ahead and find your y-intercept or any sort of intercept. So let's take a look at your y-intercept first. This might be a little quicker to accomplish. So your y-intercept, we start off with that, we said was 0, c, or to plug in a 0 into your equation. So in our case, your c value is what? Your c value is 3. So we can just go ahead and say 0, 3 and put that right into your graph here. Or you can plug in a 0. And you'll still get 0, 3. Now keep in mind what we said about mirroring, right? If you already have 1 point to the right of your symmetry line, then we can do 1 point to the left and have your next point being -2, 3. -2 and 3. This being 0, 3, your y-intercept, and your vertex. Now let's take a look and find your x-intercepts. So your x-intercepts here, we want to make sure we can factor. So when we look at your factoring, we have where you set y equal to 0 this time. So that's what we do with your x-intercept. So y being f of x is 0. Then we have -x squared minus 2x plus 3. Now, before we get started with your factoring, we do have a negative leading coefficient. So let's go ahead and factor that out before any factoring starts. changing all of your signs. So now let's take a look at how to factor something like this. So we're looking at factors of -3, 1 and 3, that can then get us to a +2. The bigger number gets the sign. So we have -1 plus 3. And if we wanted to multiply them back together, that does get a -3. And if we were to add and subtract them, that gets us to 2. Because this is simple factoring, we can then go ahead and put them right into your parentheses. If you still have a hard time with factoring, please go back to chapter 1.3, where we talk all about how to factor. So these being your fully factored form, we can ignore that negative on the outside, and instead, let's go ahead and set both of these equal to 0. So we set it equal to 0, as we did from chapter 8.1. And then we have x is equal to 1 and x is equal to -3. So this being the point 1 comma 0 and this being the point -3 comma 0. So these are your x-intercepts, and we'll put those in maybe a color like this. So -3, 0 and 1, 0. Then we can go ahead and connect your dots because you do have all 5 points here. And if you wanted to, you can go ahead and write what points that these are. Now, before we move on, let's take a look at A. So A, we said express f of x in standard vertex form and state the domain and range. So with this point now, we can state your domain and range here because we have the full vision of your graph. So your domain for any parabola will be all real numbers. And your range, well, our lowest part of your graph, right? If this extend downwards, we're going from -infinity and we're going to go all the way up until what number? We go from -infinity all the way to 4. And because we have a solid dot here, it's laying on your graph, we're going to include 4. Now, next, if we're trying to write in vertex form or standard form, there's 3 things we need. We need your A, because keep in mind, well, actually, I'll show you first. We need to recall what your vertex form looks like. So that's the one piece of it. We need to recall what your A is. In this case, A is equal to -1. And I'll put it in a different color. A is equal to -1. We also need H and K. Well, what is H and K? H and K is your vertex, -1 and 4. So with those 3 pieces in mind, we are going to then fit them into your equation. So we have y equals A being -1, x minus, and then we have -1. So we undergo a sign change. So we can say whether you sign change here or next. So this will be -x plus 1 squared, and then plus k. So your final should be -x plus 1 all squared plus 4. So now let's have you repeat the process on this one. So pause the video and see if you can try out example 3. All right, so first off, we want to figure out what your A is. Your A, if it's not showing, is going to be 1. So that being positive, we're going to be concave up this time. So, and maybe you want to say A is 1, B is -4, and C is 8. Step 2, let's go ahead and find your vertex. X is equal to -b over 2a. So you have negative times b, which is a -4, times 2 times a being 1. So we have 4 over 2, which means x is 2. So your axis of symmetry here is -2, or sorry, +2. So in your coordinate, so far you have 2, and now we need to find your y value. So let's go ahead and plug in your 2 into your equation. Two. 4 minus 8 plus 8, so 4. So we have the point 2, 4 to be your vertex. Let's go ahead and put that on your graph. Again, give some context to your graph. Maybe we go all the way up to 8. Let's see, maybe these are by 2s. So 2, 4. So right here. Okay, so that is your vertex. Now let's go ahead and find your x and y intercept. So starting perhaps with your x-intercept, or sorry, your y-intercept, well, that's just 0, c, c being 8. And your x-intercept, we are going to factor. But keep in mind, let's see, when we go to factor, or when we go to solve, x squared minus 4x plus 8 is equal to 2, or not 2, 0. Let's say we did factors of 8, 1 and 8, 2 and 4. None of these will get us to a -4, right? And even if we did use the quadratic formula, something's going to happen with your graph, because what's the shape of your graph? Well, the shape we said is going to go upwards from here. Are we going to have an x-intercept? Unfortunately, no. So in this case, even if you tried to factor or tried to solve, it's not going to work. So your x-intercept, we have no real solutions. So we're just not going to be able to graph your x-intercepts. So that just means we need to pick some other points. So let's go ahead and put, at the very least, your y-intercept on there. What you did to one side, so you went 2 to the left. Let's now go 2 to the right. So that would be 4, 8. That's the one directly next to it. And when you go to pick other points, we talked about last time picking points that are around your y, or sorry, not your y, around your vertex itself. So if your vertex is 2 and 4, we already have 0, 8, and 4, 8. Well, going 1 to the left of your vertex and 1 to the right of your vertex, that would allow us to enter in a 1 and a 3. So entering in 1 into your formula, which your formula up here is 1 squared minus 4 times 1 plus 8 will be 1 minus 4 plus 8. So that would be, let's see, 4, 5. So we are working with 1, 5 and 3, 5. So 1, 5 and 3, 5. Let's go ahead and graph those, and you have all 5 points. So if you aren't able to factor, that just means that you can either do one of two things. You could go ahead and solve it to find those x-intercepts, or based on the shape of your graph, you might not have an x-intercept. Now let's go ahead and put this into standard vertex form. So you said standard vertex form, we need A. We need your vertex, 2, 4. We need y is equal to A, x minus h squared plus k. So A being 1, we can leave it alone. X minus 2 squared plus 4. So that would be your vertex 4. So if your graph was here, we're going to shift your graph over to the left 2 and then going up by 4. Now, when it says find the minimum value of x, your minimum, right, is going to be your smallest y value. So your smallest y value here, 2, 4, would then be 4. So your minimum is at 4, or on a test, you can also put the vertex. Most likely, your homework is just interested in looking for the y value. All right, now let's take a look at example. I think this should be example 4. So it says a farmer plans to use 100 feet of fencing to form a rectangular garden against the side of a long barn. How should he split the fence among other 3 sides in order to maximize the area of a garden? So first, let's try to draw a picture. So first off, we have a rectangular garden. One side is going to be the barn, and on the inside will be the garden itself. So he tells us, though, that he plans to use 100 feet of fencing. So that 100 feet will go around this portion, those 3 sides, which means he's given us the perimeter. Now, perimeter, right? What's the equation for perimeter? Typically, it's 2x plus 2y is equal to perimeter, or equal to the 100. But keep in mind, let's say these ones are x's and these ones are y's. It doesn't matter which ones you do as x and y, as long as you keep them the same. But notice that along the barn, you don't need any more fencing. So we don't have 2 y's. Instead, we only have 1 y. So we can just say 2x plus y is equal to 100. And that would be your perimeter. Now, what we're looking for is to maximize the size of the garden. Now, we can do this in lots of different ways, but if we're trying to keep it into the context of having a quadratic, so using finding the maximum, right? Finding the minimum or minimum cost, or maybe the maximum of your graph. We can do the same with these word problems. So I'm going to show you the way how to do it using just how to max and min from like the quote unquote graphically, right? So if we're looking at the maximum size of the garden, maximum area, well, area is equal to x, just x times your y, your length times your width. So if this is what we want to maximize, right, that just means your equation here, like f of x, has to be in terms of that area. But right now we have 2 variables, and we can't have 2 variables at this point in time, right? So to maximize, we're finding the vertex. So let's go ahead and try to get it down into 1 variable. So this is where the perimeter comes into play, right? You'll notice that you have 2 variables here. So let's try and solve for one of them. So solve for a variable. Use the perimeter, use the P to solve for a variable. So we have 2x plus y is equal to 100. So is it easier to solve for the x or the y? Well, it's going to be easier to solve for the y because y equals, it's already, it has, it doesn't have a coefficient other than 1. So we don't have to make any sort of fractions. So we can go ahead and solve for y by subtracting out 2x. So you have 100 minus 2x. So that just means this y here is really equal to this y here, 100 minus 2x. So let's throw that into it. So we can say your area is equal to x times 100 minus 2x. So let's go ahead and start to expand. So we have 100x minus 2x squared, or negative 2x squared plus 100 if you would prefer. So then when we're trying to talk about the max area, right? Max area meaning the maximum or your vertex of your said graph. Well, we have the equation of your vertex, right? Now, find vertex. Well, vertex we said is x is equal to negative b over 2a. In our case, your b is 100 and your a is negative 2. So you have negative 100 over 2 times negative 2, negative 100 over negative 4. So x is equal to what? Well, x is equal to 25, which means that your x here, those are 25s. So to find your area, right, this x here is this x here. So when we want to find your dimensions and your garden, right, how should he split his garden, right, the max area, we now need to figure out your y value. We can do that in one of two ways. We can plug it back into here, or we can, we don't have to find your y if you would prefer plugging just your x in here. So let's say you wanted to find your y, we could do 100. Oh, actually, I misspoke. You do have to find your y. It does ask for the side of y. We can then put 25 in. So 100 minus 50 would be 50. So this would be 50 here. So your max area is 25 times 50, which is 1,250 feet squared. And there you go. So again, I'm looking for the approach using what you know about a quadratic to graph. Now, if you do need another graph one, I do have an extra example here for you, which I would suggest pausing the video or watching the next portion of the video, because this is our very last one. And if you don't need it, then that's all right. But this is what we're going to this is the end of our video. I'll make this new video to come.